this relatively quickly. So let's have a look. Welcome. So last time we were talking about this idea that if we used vectors, ijk vectors, we could maybe use these equations and not even worry about only doing the x's and only doing the y's, but we can only do the x and only do the y's because we have the ijk's, if you like. And it works. The only problem is some of the math I don't know how to do. Like I don't really know what to do about ijk vector squared. I don't really know how to deal with that. So the two we tend to play with, this guy here, vf equals vi plus a delta t. And we tend to deal with this next one here, which is this guy. Those are the two that we tend to play with. There's no reason why we couldn't play with this one in between. It's just that I haven't got an example of it, but it's fair game, you know. And I think last time we did this first vector, this first question, which is basically if we have a certain initial value of vi, so there's my vi, and I visualize it, even though I can't draw 3 dimensions. I'm not going to waste time trying to draw it properly, but I am going to try and visualize it. So that's going to be plus 3i minus 2j plus 4k. That's going to be meters per second. So that's going to be my visualization of VI. And then I have my acceleration. I'm going to just draw this. Again, I'm not going to particularly try and get it right. I'm just, randomly making 2 arrows on a page. But they will enable me to visualize what's going on. Did I write down the right thing on that? Minus 2 plus 4. Minus 6, that's going to be meters per second squared. And what's going to happen here is this thing's going to go in that direction, but that acceleration is going to take it kind of like that. And at some point I'm going to have a v final, and the v final would be, well, our delta t equals 6 seconds. So, going back to our old system, vi equals, list what you know, 3i minus 2j plus 4k, and that's just prompting my brain to start thinking in terms of the equations. And a is equal to minus 2i plus 4j minus 6k meters per second squared, and then I'm going to have my delta t is equal to 6 seconds. So then I go, oh, well, I want to find vf, and already my brain has already told me that it's vf equals vi plus a delta t. I mean, my brain just jogged my memory on that completely. So then over here I'll do my ijk. Layout is important in this. I don't want to make slips because of arithmetic, so layout becomes important. And I will say, well, I want vi. It just says I want vi, so vi. And rather than doing all the i's and j's, just put them in columns. So that's 3, and that's minus 2, and that's 4. And that's a delta t. That's what that's saying, a delta t, which is going to be 6 times, that is minus 12. And 6 times 4 is 24. And 6 times minus 6 is minus 36. And that equation tells me to add these guys together. So then I'm going to go, well, that's going to be, what, minus 9i. And this is going to be plus 22j. And this is going to be minus 34k. I think I did that right. So my answer is minus 9i plus 22j minus 34k. It's going to be meters per second because it's a velocity. It's vf is equal. And I hope that's right. I'm going to just give it one more check over. Did I not do that right? 132. Thank you. Yes. 32. So slips happen, but you can catch them if you try. If you don't try and catch them, then you've got a slip, and that's an issue. So not bad. It works. It was just a 3-dimensional constant acceleration problem. I mean, it's kind of amazing. I could have called this a projectile, in which case I would not have needed to give you that, because projectiles are only acted on by the force of gravity, and so they only have a gravitational acceleration. If I'd said that if it was a projectile, then a would equal 0i, because there's nothing in the x direction. minus 10j, because there's minus 10 meters per second squared downwards, plus 0k. So I could have done that, just giving you a bit less information, but because you know what a projectile is like. And there's a diagram I'd have for that where this, A is pointing downwards, and you multiply it by t squared. I can call it g here. Sometimes the old book used to call it g. I hate it. It's not special. It's just the acceleration due to gravity. It's just, why make it special? And this next one, a projectile has an initial velocity of that. What is the vector displacement after 3 seconds? Oh, yeah, projectile. So I just did that. Is that the end of it? Yeah. So did I do this one last time? Did I do it? Yes. Okay, so look back at the old tape then. Okay. So bit of a line. Draw a line, because we're going to do something with vectors, which is in 3 dimensions, but it's all about velocities. I don't know if you ever did. I remember doing aptitude tests when I was a kid, and they'd have Johnny gets on the bus, Johnny runs to the back of the bus with a certain speed, the bus drives forward with a certain speed. What's Johnny's speed relative to his mom who's stood on the sidewalk? And it's like you're going, well, do I add these things or do I subtract these things? And it's like this, trying to see, can you do this in your head? Can you mentally kind of visualize it? And actually quite hard, because you're on a number line and it's positives and negatives, and the tendency is not to formalize it. 3 dimensions, you've got to formalize it. And we'll go back to our vector diagram again. So let me ask you, this will come up in physics 2. We just did an example with this in physics 2 where students were expected to know this. If you think back about your vector diagrams, I'm adding 2 vectors together, and they are equaling a third vector. And I know that because of the way the arrows are pointing. So can you see how I am adding together those 2 vectors? Because the tail of one sits on the head of the other. I'm certainly not adding those 2 vectors together. I'm not adding there, those are 2 tails. And I'm not adding there, those are 2 heads. The process of adding is drawing the tail of the second vector on top of the head of the first vector. So what this says to me is, my answer is VC. VA to C, the velocity of A relative to C, is equal to the velocity of A relative to B added to the velocity of B relative to C. So that's how I draw it out formally. Notice, if you want to memorize this, you start with A in both cases, because the vectors both have to start at the beginning. And you end with C in both cases, because the vectors have to end at the end. And whatever's the intermediary goes in the middle. So it goes A to B added to B to C. You've got to get that order right. It's got to start with A and end with C and have B in the middle. Now we're not going to work with A, B and C all the time. We're going to work with the submarine and the aeroplane and the swimmer. Or we'll have John and Carol and Bill. So something, just to name these things out. So here's a good example. John has a velocity of that relative to Bill. Lisa has a velocity of that relative to Bill. What is the velocity of Lisa relative to John? So, all right. So I'm going to say, what do I want? I want Lisa relative to John. VLJ. Lisa relative to John. And that must equal VL. And then added to V something J, because Lisa has to be at the beginning and John has to be at the end. And then Bill is in the middle somewhere. So it's Bill goes in the middle there and Bill goes there. Okay. So then let's do our list. So we say, well, our velocity of John relative to Bill is equal to, notice we started with John relative to Bill. Get the order right. That's going to be plus 3I plus 2J plus 4K meters per second. And then the velocity of Lisa relative to Bill, so Lisa relative to Bill equals minus 2I minus 3J plus 4K meters per second. And then I try and do it. So I'm going to say, okay, IJK and my equation tells me I want velocity LB. So let's have a look. Oh, I've got that, haven't I? I've got that exactly. That's nice. So I just write that in. Minus 2, minus 3, plus 4. And then I want to add on to that Bill relative to John. And, oh, I don't have that. I have John relative to Bill. Notice the order's backwards. The order that it's written down matters. You've got to interpret, is it me relative to you or you relative to me? That makes a huge difference. Well, I can change that. It's just going to be the opposite. If that is that, that is that. It's just the opposite. So just change the sign on everything. So that's going to be minus 3I minus 2J minus 4K. Is that clear? If you want the opposite of something, the opposite vector has the same magnitude, so the numbers don't change. Just the directions are all opposites. So the opposite x component, the opposite y component, the opposite z component. Okay, so that's going to be minus 3, minus 2, and minus 4, and then we add them up because it tells me to add. So that's going to be minus 5, minus 5, and 0. So my answer would be minus 5I minus 5J plus 0K meters per second. Never forget your units. There we have it. Not bad. I didn't do a diagram. Maybe I should have done a diagram. I'd have said I want velocity, Lisa, John. So I got to go down here and say it's Lisa, Bill, and then V, Bill, John. So that's what I'm doing in that equation. They both mean the same thing. Clear on that? It's practice. It's just knowing the equation. What do I look for in a test? I look for, do you have this equation? And is it right? I'll look for the answer, of course, but questions? No? Everybody okay? Okay, cool. Let's stop this here.